Hi friends, welcome to my channel. Let us see the mesh analysis method, that is super mesh concept. With the help of both voltage source and current sources are connected in the any kind of circuits, that is the DC circuit. So this is the example for super mesh concept. So there are three meshes are present in this given circuit. So first mesh consists of 8 volt source and 2 ohm resistors are connected here, and 3 amp current is flow through this 2 ohm resistor, that is in between of I1 and I3 meshes. The 3 amps current flow through this resistance value, and I2 is the second mesh and I3 is the third mesh. So with the help of super mesh concept, here we can find I1 current, I2 current and I3 current. So let us move to solution. So in this circuit, super mesh concept can be applied due to current source given in the circuit directly. So in between of two meshes. So according to this circuit, there are two possible ways are available. That is the source current Is is in only one mesh. That is I mesh can be equalized to Is. So the Is between two meshes are denoted as super mesh, and with the help of KVL and KCL concept, we identify the super mesh in the given circuit. So from this super mesh, we can easily find the three currents I1, I2, I3. As usual, what are the procedures we have followed in mesh current analysis method? The same should be followed here also, and we have to write the equation for different meshes, and finally we can form the matrix. After matrix, we can find del value, del 1, del 2, del 3 values. Finally, we can able to find the I1, I2 and I3. So now we have to consider this given circuit. This particular area is called as the super mesh. That means 3 amps current source is connected in between of I3 and I1. So and the current is flow through this 2 ohm resistor. So this particular portion is called as the super mesh. And now we can redraw the circuit. So the same source 8 volt is retained here, and 2 ohm resistor, 6 ohm resistor and 4 ohm resistor also retained. Now we have to remove this super mesh area, and we have to consider this entire two meshes, that is I1 and I3 combined in a single mesh. So this is called as a super mesh. So remaining all three currents I1, I2, I3 as usual passing through this particular meshes, and the remaining resistors and voltage sources taken place as it is what we have seen in the given question. So we have to now apply the mesh equation for super mesh. So at super mesh, we have to write the equation. So here the current is flow from negative to positive. So we can put minus 8 volt plus 2 into, here this 2 ohm resistor is connected in between of I1 and I2 mesh. That is from mesh 1 and mesh 2. So the two resistance value is multiplied with the difference of two currents I1 and I2. So 2 into I1 minus I2 plus this resistance 4 ohms is connected in between of I2 and I3. So now we are going to consider this particular I1 and I3 and also the entire super mesh. So 4 into I3 minus I2 plus 2 into I3 equal to 0. So this is the equation for super mesh. So now expand all the entire equations. So all expressions can be expanded, and we can separate I1, I2 and I3. Finally, we get the equation 2I1 minus 6I2 plus 6I3 equal to 8 volt. So we can consider this is the first equation. Now we move to mesh 2. So that is this particular area. So we have to find the equation for mesh 2. 2 into I2 minus I1. That is this 2 resistor into I2 minus I1 and 6 into I2 plus 4 into I2 minus I3 equal to 0. So this is the equation for mesh 2. And expand this expression, we will get the equation finally minus 2I1 plus 12I2 minus 4I3 equal to 0. So this is second equation. So at last we can write the expression I1 minus I3 equal to 3. That means what is the current flow through this 2 ohm resistor. This particular area is called as the super mesh. So this current 3 amps is connected in between of mesh 1 and mesh 3. So I1 minus I3 equal to 3 amps. So the equation is I1 minus I3 equal to 3. That is third equation. So now we got all three equations from the super mesh circuit. Now form the matrix. So from first equation 2 minus 6 plus 6 can be taken for I1, I2 and I3. And from second equation minus 2 plus 12 minus 4 can be taken for I2. And the third equation 1, 0 minus 1 can be taken. That means in third equation there is no I2 current is present. So we simply put the 0. So and I3 current is taken place here. So finally at last the right hand side values are voltage values, that is from first equation 8 voltage and the second equation 0 volts and the third equation we have 3. So these all values are taken in this matrix. Finally we form this matrix clearly. From this we can able to find the del value. We simply take this only matrix. Finally we get all the values for this del value after calculation. That is this first row and first column can be considered here. So 2 into 12 into minus 1 minus of 0 into minus 4. Next minus second column and first row should be considered. So minus 6 into minus 2 into minus 1 minus plus 1 into minus 4. And the third column first row should be considered here. So 6 into 0 into minus 2 minus of 1 into plus 12. So after multiplying and subtracting all those things, finally we get minus 24 plus 36 minus 72. So del value is equal to minus 60. So after that we have to find del 1. So simply we can say this del 1 can be equalized to del I1 also, because we need to find the I1. So for that we have to find del I1 or del 1. So here the right hand side voltage value 803. This can be put in this first column from this matrix. So 803 and the remaining two column values are retained as it is in this del 1. So after that again we have to apply this procedure. First row and first column should be considered and remaining parameters are multiplied and subtracted. We get minus 96 plus 72 minus 216. Del 1 answer is minus 240. So I1 can be determined with the help of the formula del 1 divided by del, that is minus 240 divided by minus 60, which is equal to 4. So I1 is 4 amps. Similarly I2 first column can be retained as it is. What is the del value? The same 2 minus 2 1 is present in this del 2 and the second column is replaced by the right hand side value, that is the voltage value 803, and we apply all this value and calculate everything. We get minus 60 is the del 2 value. So now I2 is equal to minus 60 divided by minus 60. Our answer is 1. So I2 is equal to 1 amps. Similarly, the same procedure is applied for del 3 also, and the last column is replaced by the voltage values 803. Remaining first last columns value replaced by the voltage source value, and the first two columns values are retained as it is. Finally we get again del 3 value is equal to minus 60. So I3 equal to del 3 divided by del which is equal to 1 amps. So from this given circuit, by applying the super mesh analysis concept, finally we determined I1 equal to 4 amps I2 equal to 1 amps, I3 equal to 1 amps. So this is the super mesh concept. So whenever the circuit is complex, at the same time the current sources are connected in between of multiple meshes. At the time, instead of a simple mesh analysis concept, we can apply to the super mesh concept when the both voltage source and current sources are present or available in the given circuit. So I think everyone understand this concept clearly, and hope everyone like this video. So once if you understand all the concept, kindly subscribe my channel and put the likes. If you have any doubts, give some comments. Surely we will make it as a positive points, and in future we will change it as a different way. Thank you all.